for a long time at Compass now, we've been working on something called microsimulation, where you simulate individual units, development across time, and you treat it as a virtual cohort to do things with. So what happens if this intervention happened to the group? How will that affect them? And I'll talk a little bit about what we've done with the Better Start Natural Science Challenge, where one thing the Better Start Natural Science Challenge, I'll get onto this, did is across its various domains, which are healthy weight, resilient teens, so sort of mental health in teenage years, and successful learning, ran various interventions. And we were able to build them into a model, building off the work that we'd already done. So the basic idea here is, if you want to evaluate the impact of a policy change or intervention, you could actually do the policy change or intervention and then wait to see if it worked and then report back on it. But that's expensive. And so one alternative to that is, if you set up a simulation model that represents the population well and represents the impact of whatever it is you want to intervene on well, you can use the simulation model to do the work for you. So taking a step back, in our earlier simulation models, we had this grand idea that it would be a policy tool that we could hand over to the government departments that they'd use. That didn't quite work, but nonetheless, the sort of potential, I think, is still there. And simulation models are being used in New Zealand, often for fiscal things, but other things as well, I think. And not so much in the work that I'm going to show you, but you can also model the complexity of multiple associations and pathways, where single interventions can affect lots of different things, for instance, and can affect things through different pathways. And so the idea, as I intimated before, is you simulate plausible data from micro-level units for everything we do, being a sort of social science research centre, it's people. Uses, hopefully, it doesn't have to be empirical. You can make stuff up if you like, but use empirical data as a basis to simulate real alternative worlds and their futures. And in so doing, you're creating this virtual lab that you can play with. You start with a real or realistic sample of people. What we've had a history of as well is creating synthetic data from administrative data. So this is the one use of the integrated data infrastructure for this particular project, is to generate a population of individuals, 10,000 individuals, that look like real children born in 2013. Then apply statistically derived rules, or rules more generally, to reproduce patterns via stochastic process. So it's simulation. So the overall impact of something you might estimate to be a certain level of impact. It might double the prevalence of something, to give an example. You simulate it through, so each person who has that intervention gets double the chance, but they may not necessarily have that outcome. And it changes each time. It's a stochastic process. And in so doing that, you're creating a virtual world, and you can predict what might happen if conditions were to change by altering parameters, for instance, or saying there was a particular policy or intervention that came into place. Okay, so the Better Start simulation model, as I said, the Better Start National Science Challenge had 3 focus areas, extended out to a couple of others that weren't really amenable for simulation, but 3 focus areas that were successful learning, healthy weight, and resilient teens, and all had an intervention of one form or another. For successful learning, it was something called, and I'll get onto this in the slide, I think, the Better Start literacy approach, which was a first year of school, a sort of structured literacy approach. This has got into the media more over the past couple of years, I think, around the fact that the literacy of New Zealand children hasn't compared well to the literacy of children overseas. This is a literacy approach that appears to work really, really well. And the healthy weight, there was a moya moya intervention that isn't quite complete yet, so we could work that, which was a sleep, or it was an intervention on healthy sleep behaviours, really, that may or may not have an impact on weight and obesity. That's still being sort of finalised. We didn't put that in the model, but what we have got is this prevention of obesity in infancy intervention, which was a couple of interventions, one sleep one and one sort of information one, and the sleep one was the one that seemed to have an impact. So we modelled that. And then we also modelled something that wasn't an intervention, but there's data on smoking, pregnancy, and on weight. And then the resilient teens group have a suite of digital interventions that became prominent actually during COVID, sort of for well-being and those sorts of things. So digital interventions to help people going through problems with mental health in one way, shape, or form. And one particular one that we've modelled is on stress in sort of at late adolescence, early adulthood, and its impact on well-being. Okay, so the Better Start Literacy approach, it's this evidence-based literacy teaching. So they train the teachers to teach literacy in a certain way, and it builds on kind of phonics. So teaching sort of this phonics to children about the sounds of words and how they relate to each other. This is a quote from Gail. Sorry, I should say as well, the people that I've worked with on this. The Better Start Literacy people are Gail Gillen at the University of Canterbury, Bridget McNeil, and Megan Gath as well. So teachers monitor children's response to the BEAR SLA teaching, then scaffold adapt activities, increase teaching intensity as necessary to ensure all children progress towards their next steps for learning. And I haven't got it here, but when I give a longer talk on this, it's just night and day, the extent to which this does suddenly increase the children's ability to recognise words and other early literacy indicators. Sort of 6 months gain, essentially, in schooling and literacy. The prevention of overweight in infancy trial. So one of the rationale for this is there's very high prevalence of overweight and obesity in New Zealand and elsewhere. New Zealand, I think, third highest rate of childhood obesity in the world, and there's long-term consequences for that are hard to change once established. So one way to prevent those long-term outcomes is to have a sort of early intervention. There's a grown now probably body of literature on the impact of sleep on increased weight. So getting more sleep is a good thing, getting less sleep is a bad thing. And so the question is they looked at whether a sleep intervention reduced the odds of obesity or overweight in childhood, and they showed that it did, at least in the short term. So in the short term, it halved the odds of obesity. That washed out in the longer term. So that's in early childhood, washed out through to mid-childhood, which we do program into the model. And then this is one of the range of digital apps that were created by the Habits team, Health Advances through Behavioural Intervention Technologies. Oh, sorry, going back, Rachel Taylor and Barry Taylor, mainly Rachel Taylor was the main person working on the obesity intervention. Here it's Sarah Hetrick and Tana Cargo and Carolina Stasiak, who's worked on the Habits suite of interventions. One was called Stress Less, and so it's this digital app. So you get on your phone, and this person called Araha, I think, pops up, and this kind of back and forth chats across a 21-day program. I think broken into 3 bits, but building on cognitive behavioural therapy and positive psychology. And it's sort of 3 to 5 minutes a day, and it was shown actually to improve well-being in 18 to 24-year-olds students, and that's what we programmed into our model. Okay, so so this is a model that anyone can use. So if you go to that website there, you can go around and go into that and play with the model. One caveat is we still haven't finalized the user's guide that would really help you get underway with this. But I'll show you a few things that it can do. The IDI disclaimer is there because, as I say, we did use the integrated data infrastructure to create our synthetic base file that we start people with. There's, as well as Lisa's briefs, there are also briefs at the back. One that describes the model generally, and I think 4 others that describe each of the interventions that we worked on, the 2 obesity ones, the literacy one, and the stress less one. Okay, so this is what you see when you go into the model, and it just describes what's in there. I'll take you through some of these sort of tabs on the left. The model inputs show that the next year. This is what the model inputs show. This basically just replicates what we've built into the model there, and it's modular, this model. So the thing about it is, if someone came along and said, "Hey, I think it would be great, and I have funding for you to add these other things to the model," we can do it. Unlike our earlier models, such as the Knowledge Lab 1, one called Knowledge Lab that had lots of intersecting things going on there. This is really purely modular. We're just modeling those interventions there. And model builder I'll get onto. The scenario builder is what I'm going to take you to next, where you can actually say, okay, I'm going to play around with this. I want to see what happens to the population when we do something. So we start with a population that hasn't had anything happen to them. And the way their trajectories are determined by data that we've derived from New Zealand data somewhere, New Zealand Health Survey, other data sets that model literacy. Just trying to think where we got literacy stuff from. That's from Pearl's data set, actually, yeah. And so this is the model starts off assuming you haven't had this intervention, and what you can do with the model is say, well, what if people had it? So what I've set up there is if 50% of the population got the Better Start Literacy approach, what would happen? And what we know actually is that if you improve children's early literacy, that has a flow-on effect to their later literacy as well. So we do two things. We do a impact on their early literacy as measured by ability to recognize word sounds, the phonological awareness, and then later reading comprehension. The reading comprehension thing is from the Pearl's data, which people have been wringing their hands about in terms of New Zealand's performance against international other countries' literacy performance. So what you do is you plug in what you want to what you want to do for a change, and there's various other things you can do, which in the interest of time I won't go into, but there's got the select subgroup formula over here. So you could just target this intervention to a particular group of the population by gender, by ethnicity, by deprivation, and by a few other bits and pieces. But what we've done here is just target it to the whole population. And what you see here is the red is what's known as the base scenario. So that's what would happen if no one had the intervention. And this shows what happens to the whole population if they did have the intervention. I've broken up here by different ethnic groups. And the reason I've done this is you see really quite stark effects for Māori and Pacific. And this is this is building on the data that was sent to us by the people who did the Better Start Literacy approach. They were showing these size effects on early phonological awareness. Knowing what we know about the impact of that on latent reading comprehension, again, this is based on Pearl's data, that's the sort of size effects that you see. And this is based on the Pearl's data where the average across all countries is set to 500. I think there's a standard deviation of 50 or something, yeah, something like that. But anyway, this is what it's based on. So this is New Zealand data on what is going on at the moment and what we think would happen if half the country got the Better Start Literacy approach.
What's the time horizon on
that? That is 5 years between the early phonological awareness and the Pearl's assessment, which I think is age 11. Yeah, something like that, yeah. Okay, next one. Stress and well-being. Okay, so here we've got this stress-less intervention, and what the data suggests happens is that those who have it have an improvement in their well-being as measured by the WHO well-being scale, which runs from 0 to 100, of about 7.38 points. Okay. And if you did the same thing again, say, well, what if half the population got it and half the population didn't? What would happen? Which is what we're programming here. Just on the left-hand side here, you get to name what your intervention is, and that's all saved in there. So you can compare this intervention to the base, and you can set up lots of other interventions, compare those to the base. And overall, that's faithfully replicating back to us what would happen if half the population got something that improves their well-being by 7.38 points. Let's go from 0 to 100. But the other thing that is new in this model that we haven't done with previous models is people say to us, well, you know, that's a idealized intervention that's happened here, that you've got that size of effect. Things in the real world normally aren't as good as that. Can you model what would happen if it wasn't quite as good as the intervention? And so you can, and this is what this model builder does here, so you can go and say, well, okay, what we've programmed in there is a effect size of 7.38, but actually, what if it's slightly less than half of that? We're setting up this new model, I'm calling it SL3, where the effect isn't 7.38 points, it's only 3 points. Okay, and you program that through, and you see obviously a smaller effect there, so the change is less. Now you may think, well, that's kind of obvious, but what this means is you can, and this is flexible, right? You can go through and program whatever you like to model as a tool to see what might happen. Different things you might be thinking of, with a range of effect sizes, right? So you're thinking, well, I idealized, if it works as well as the study suggested, is it looks like this. But even if it's half as good, we still get some sort of effect going on here. And you can play around with at what level it would need to be less in terms of for you to see something that has an effect that is important to you. A step on, which we have not done, is you could monetize these if you really wanted to. So what does it cost to implement the interventions that we're talking about here? And what would be the savings in terms of improvements to these outcomes for children? Okay, so that was a sort of whirlwind run through. I focused on 2 interventions, but there's sheets there for 4 of them at the back. Microstimulation is a flexible way to test the impact of policies and interventions, and we have set up one based on the Better Start Natural Science Challenge, the interventions that they developed, and got 4 things in there at the moment: smoking pregnancy on weight, sleep intervention on weight, Better Start literacy approach on literacy, and the Stress Less digital app on mental health. But it's modular, as I say, you can add more things in there. One thing I didn't show you, but it's possible, is you can target interventions. So what if the intervention wasn't just on the whole population? What if we ran it on just this particular group? And so if we run an intervention that had 75% of this particular population, how would it affect both the overall population, but just that particular group as well? In those graphs and tables that I've showed you, that's just looking at what happens at the whole population. You can dive down into it a bit more and see, well, what happens to specific populations. I did that actually with the Better Start literacy approach, showing you for the different ethnic groups. And yes, so it's still in development. It's more or less developed. Thank you to Eileen, who helped with the development of this, and Kevin Chang, who developed some of the earlier models and has passed on his knowledge to Eileen about how to develop these things. And you can go there and play around. If you wanted to do that and you weren't sure quite where to start, and you want to do it before we finalised our users guide, just get in touch with me and I can talk you through it. I'm very happy to do so. And if you've got any other ideas, any questions about this, or any other ideas of what might be interesting to do with this type of thing, let me know.
Just a quick question about that Stress Less one. About you put in the effect size. What's the underlying stochastic component? How does that deterministic effect size get played out as a stochastic measure? Okay,
so there's basically a regression model in the background there that in the initial case had the 7.38 points, and we're flowing through the regression model, and with a bit of error around that effect, we simulate everyone's overall score, whether they had it or whether they didn't. That effect size, or that parameter, changes from 7.38 down to 3. You also have to change the intercept to get the overall numbers going up correctly, but that all changes in the background, and then that's what flows through. Does that make sense? Yeah. And in the more obvious case is if you change the odds ratio of something, it generates a probability of being a something or not being that something, and that's stochastic. You roll the dice, you've got a 70% chance of getting it, and 70% of the time they will, 30% of the chance they won't.
Yeah, question about the wellbeing intervention as well, and just thinking about that scaling up of a wellbeing intervention to population level. and you mentioned you could do some targeting to specific populations. Is there any way in which you think you could kind of target to the types of individuals that were more likely to participate in that sort of wellbeing interventions? You know, there can be quite a difference between, say, participation in a small intervention compared to large scale rollouts.
The answer is, I mean, in theory, yes. In practice, what we're programming into the targeting part of the model may not pick up on all the things that you want to pick up on. But if there's data out there at the population level that describes the population that would enable you to do that, absolutely. It's just another, what is it? It's just another characteristic of the population that you can then drill down into to say, yes, we want to focus on that group. So in theory, yes, that would be an add-on, but in terms of add-ons, that would be a relatively, if you had the data to support it, to tell us, well, I want, the data looks like this, it affects 70% of the population, this particular variable, whatever it is, and it affects these other groups differently, we can program that in there. But probably not in there at the moment.
This might be maybe a dumb question, but just thinking about sort of varying the effect size and things, I was wondering if there's a use for this kind of model in terms of, I guess, figuring out what kind of, say, you know, an outcome that you want to achieve for the population, what effect size do you need from an intervention to get there, and then therefore kind of being, I guess, backwards.
Yep. The answer to that is yes, in a sense, but it's not set up in that direction. So it would be trial and error, but it wouldn't take you long to go up and down to work out the size of effect you would need to have the effect that you're looking at, with the proviso that this is an effect played out to this percentage of the population, or maybe this percentage of the population who meet these characteristics, those sorts of things. So yeah, absolutely, it's possible to do that, but it's not set up to go in that direction. But there's a workaround, I think is the correct answer.
We've got one question here, which is, what information would you need to factor in school attendance on literacy?
Okay, thank you, Bart. What information would you need to factor in school attendance on literacy? You would need to have some data on the impact of school attendance on literacy. And intriguing you should ask that question, Barclay, because I did a bit of literacy searching on this, leading into a grant application I put in. So if you had good information about the impact of school attendance on literacy, and you had good information about the level of school attendance in New Zealand and how it may differ by whatever it is you want it to differ by, yes, that's what you need to put in. And the other question in there from Finn O'Keefe is, how are you generating the initial synthetic population? Okay, very long story short here. We generated 10,000 real individuals within the IDI environment who had various characteristics, and we found their 20th nearest matches and took an average of all of the characteristics across those 21 individuals with some noise added, output that, which passes the output rules because it's a mean with a denominator of at least 20, and it's a mean with a denominator of something divided by 3. And then on the outside, we use that to generate an actual synthetic base file. So what we get out from the data lab is the ability to generate, is probabilities of having characteristics, essentially. So just as an example, one thing that you find there is if you find someone's 20 best matches, males tend to be matched up with 20 other males, and females tend to be matched up with 20 other males, which gives you no variation. We added noise so that we did have some variation there. Otherwise, we're essentially identifying individuals. For each of the characteristics we had, most of them were categorical, weren't they, essentially? So you got a probability of being something. But for others, that was like birth weight, to be an example. So birth weight, we get the distribution of birth weights. Everyone's in there has got a birth weight. We match them to 20 other, each individual, each of the 10,000, 20 other individuals. and then we create an average birth weight there, and that's what we get out, essentially. And that, on the outside, we generate synthetic base bar, and we've done some work, Eileen has done some work, showing that that looks like the population we start with, and all the things we kind of, well, all the things we put in there, essentially. And this is building off work that Christopher Ball at Reserve Bank did for his PhD, as part of his PhD, where he used this process to generate synthetic household economic survey data, I think. So, and it's a really clever method to generate synthetic data, I think.